Hello there, my name is Luke Evans and this is my PowerPoint on applying systematic software testing to a use case. So what is software testing? Systematic software testing is a vital part of the verification process for the software that is being developed. Testing is done to verify that software meets the requirements that were set out for it to guarantee the system is performing as expected, ensuring it is secure, efficient and scalable. This will be done using multiple testing types. Testing will identify defects and errors within the code that may have been missed by the developer, which may lead to the software encountering issues and not doing the intended job it was made for. This makes systematic software testing an essential step in the software development cycle. The goal of this presentation is to demonstrate why software testing is vital for creating a sustainable system, as issues with the system will be identified. The chosen case study. The chosen case study is an application form for a university. The program will require users to enter personal details for their application form to university. Testing will be a key aspect for this program, and we need confidence the data validation is working correctly so that no defects within the data can be submitted, as this would mean delays within the system and for people at the university, as they would need to rectify the incorrect information, leading to increased costs and maintenance. So the scope of testing was conducted to identify that these 5 features that needed to be tested. These are user login and registration, user's complete name, user's date of birth and age, and user's subject they are applying for with the required grades they need for it. And also, lastly, performance, security, and usability of the system. To test these functions, we will be using functional and non-functional testing. Functional testing will focus on validating the features of the system, and non-functional testing will be used for the performance, security, and usability of the system. So there was 4 key testing objectives for this test phase. These are: identify and rectify any errors or bugs found within the system under test to improve confidence that the software is functioning as the design phase stated. 2. Validate all requirements that were set out before testing, including both functional and non-functional requirements for complete test coverage. 3. Comply with coding standards through the use of a static analyzer. And lastly, improve the software's performance, scalability and security through the use of testing these aspects and improving them. Unit testing will be the main source of testing conducted in this test phase. This is where you target specific classes and functions within the source code to isolate the errors that may be there. We will be unit testing all functionalities individually to verify they work, which will overall create confidence in the whole system and generate full test coverage. Unit testing can either be black box if the test case is focusing on inputs and outputs, or it can be white box as we need to know what the source code is held within these classes, methods and functions. Design of the source code must be of a good standard as it correlates to the ability for a unit test to be able to function. Making a unit test a repeatable procedure was key so that it can grow with the source code as that grows as well. This will make a sustainable and reliable system. I will also be using assert quite a lot in the unit tests, as you assert a value to be true for the test case. If the value is not true, most likely the test case will fail. A unit test will either result in a pass, fail, or error. Static analyzers will also be used. The role of a static analyzer is to identify defects in a software model and source code, as well as the compliance of code, as a flaw in either of these can result in a possible security risk. They are able to identify defects within the code without execution of the code. They are very effective at early detection of defects. For this system under test, the static analyzers that I used were Pylon, Flake8 and Bandit. Pylon and Flake8 were both used as false positives are possible when running these, so I could compare the results of both to eliminate this risk. Pylon produces a score out of 10 on the coding, on your code compliance of code and detecting errors. Flake8 checks the Python code against coding style PEP8 along with the detection of errors, and Bandit is a security static analyzer checking potential vulnerabilities like SQL injections or hard-coded passwords. For this test phase, I went through the 6 phases of the software testing lifecycle. First, requirement analysis was conducted to gather all functional and non-functional requirements and enter them into a requirement traceability matrix so that test cases can be mapped to them. Then, functionalities and features to be tested were identified, and then we had to establish when we can conduct testing, for example, when the source code is ready. Multiple test cases were then developed, which involved the creation of a tabular format of preconditions, test steps, requirements being tested, and the expected results. I then had to set up the environment, creating a robust testing framework that would give the exact results it should be. The environment must replicate how the system will be used within the real world, and also a tracking sheet to record the results was created. Test execution was then conducted, following the verification dashboard and executing test cases one by one. These tests were both manual and automated tests, and all defects and bugs were tracked within the verification dashboard. And finally, the test cycle closure. This involved the analysis of the test results, make sure that all test cases were documented within the verification dashboard, and get approval of the exit of test cycle from stakeholders like managers or investors. For the test case design, it needs to be clear in what the functionality is being tested, how it is being tested, and what the result of the test case should be. Test cases will incorporate a step-by-step process on the actions to be executed. As you can see on the right, you can see the script steps. To be classed as a good test case, these 3 key features were identified. Having testing techniques incorporated to them, for example, equivalence partitioning, which is when you partition valid and invalid data, so I don't have to run multiple test cases. For example, the system can only allow users from the age of 18 to 65, therefore we only had to test 17 and 66, not 90, 80, 70. And boundary value analysis was used to target the boundaries specifically, as a lot of errors can occur here. For example, the 18 to 65 values. I also needed to make sure that test cases map to at least one requirement, giving it purpose, and I had to understand how the user will interact with the system, making sure I cover for any errors they may make, for example, not entering input, so I had to test for null values. So these are examples of test case design. Test case 8 is the expected failure for this to show how I track these failures. And I also have examples of boundary value analysis, use case testing, as well as non-functional security testing and a decision table test, which showing that all paths were covered. The outcome of the application of test cases. Overall, all 32 test cases were run in this test phase with 29 passes and 3 fails. This shows that overall the system is performing as designed on most functionalities. The biggest worry of the system is that the login functionality allowed incorrect passwords to enter the system. This cannot happen, as this means unauthorized users will be allowed in the system. The results of the static analyzer were very good. It showed that the quality of the system was high. PyLint and Flake8 gave some warnings. After investigation, they were not serious warnings. However, they can be fixed at a later date. The system was also deemed to have no security vulnerabilities using Bandit Static Analyzer. As you can see, I've also included the verification dashboard of all test cases that were run, showing pass and fail rates. So the key insights of this test phase, it was essential in gaining confidence in the system. Unit tests were vital for this test phase, as there was multiple functionalities within the system that had to be targeted individually so that I could identify the bugs and errors and defects. There were some issues with functionalities of the system. However, these will be investigated, then the software will be updated, and then the regression testing will occur, as we need to make sure that all test cases are still passing, and the test cases that failed will now get a pass. I'll now take you over to the demo of how I executed the test cases. So the test environment is Visual Studio Code, and the framework used was PyTest. This was chosen as it gives effective output logs, allows for a number of plugins, so I could run all test case types like performance and security. And it also has assertion introspection. This shows the actual values involved in the assertion, not just that the test case failed. It says why it failed. So as you can see here, this is a test case for date of birth and age validation. I've classed it all together within one test, as I found this a simpler and neater way of running the test environment, as we had multiple test cases, so it just kept it simple. As you can see here, this is a login for the output file and imported the module and class. And as we go down, here is all the test cases involved, as you can see here. This is a test case that is expected to fail, as we set it to false, as we don't want the user to be allowed to register. So I'm now going to execute the test using this line. This line is very effective, as it makes sure Python-m makes sure the environment is consistent for all tests. Then we have the test case that actually wants to be executed, for example test_date of birth. And then we have -v, as it gives a more detailed output showing test name and status, either pass, fail or error. We have -s to allow print statements to be shown. And then we have the output file name and 2 and 1, which will include both pass and fails all in one file. So we're going to execute that. Then we're going to go over here. This is all my output files. This is easy to keep track of. I did this to keep a log of everything for traceability. As you can see, we have test case name and the status here, like I said before. And then sometimes it prints the statements if we want it to be true. This case failed because it still allowed the user to be able to enroll even though they were under the age limit. This is the actual summary of the fail. This will happen for all tests, however I've just done one here to demonstrate how effective it is. So I can see that there was a problem with the assertion error, as it should be, as it is allowing this user, however it should be a false statement. It should not be allowing this user. Overall, this is my whole system. As you can see, each test case here, we have the Python module here, and each test case follows the exact same format. So, multiple tests for the one specific class. That'll be the end of the presentation. Thank you for listening.